Okay, I'm back. All right, so first example on page 12 says, let M be the line passing through the 2 points, and it gives us, kids ruined my markers, the points -1, 2, 3, and 4, -1, 5. So M is a line that goes through those 2 points. Describe M with a vector equation. Well, this is a vector equation. The things I need for a vector equation, I need a point on the line. I have 2 to pick from, so that's good. But I need a parallel vector. Neither of those was a parallel vector, so it's not like I can just go, oh, I'm going to put that there and that there. That doesn't work. This has to be a point. This has to be a parallel vector. So how do I get a parallel vector given 2 points on the line? I subtract them. Because those 2 points are random 2 points. And what we've learned from the beginning of the packet is when I subtract them, all I'm doing is moving them to the origin. So I'm treating them like a vector. So when I take those 2 points and subtract them, it actually doesn't matter which way I subtract them, okay? What did I do? I did 4, -1, 5, minus -1, 2, 3. When I subtracted them, I got 5, -3, 2. So that is my parallel vector. The reason it doesn't matter what order I subtract them in is because if I subtract them in one order, I'll get a vector like that. If I subtract them in a different order, the opposite order, I would get a vector like that. Both, direction doesn't matter here. Both are parallel. Okay, so here's how I write the actual equation of line N. I'm gonna go over here. X, Y, Z equals, I can pick either point, it doesn't matter, both those points are on the line. On my answer key, I picked -1, 2, 3. Plus, you need a T there. And then I'm gonna put next to that T the parallel vector I just found. There's the vector equation for line M. Now, it doesn't ask me on page 12, the page I'm on, it doesn't ask me for the parametric equations, but on the homework it does. So, here's how you would write the parametric equations. X equals -1 plus 5t. Y equals 2 minus 3t. Z equals 3 plus 2t. Those are the parametric equations. Okay. From there, I think we're good for 1 and 2 on the next page. You can try those. I'm not gonna do those. I'll just scan my answer key and you can see it. But what I do need to do is the very last thing. So that's a vector equation of a line. It gives you a line. The reason it's called a vector equation of a line is because you use a parallel vector in it. Okay, so this is an equation of a line. I know I'm emphasizing that because the very last thing I'm going to do is a vector equation for a plane. Now, when I'm teaching this day, under normal circumstances, the first thing I would do is put that's probably enough. I would write this on the board. And I would say, what shape is that? And put yourself in the space of a regular classroom and think about what you would say as your answer to that. tell you what a lot of people say. Oh, an ellipse, a circle. I get those kind of answers. Both of which are wrong because we don't have any squared variables. This is a line. It's a line in standard form. I could solve that for y. So when I do this to it now, it's a plane. Okay, so it goes from having two variables, x, y, to three. I do have my model here. Oh. X, Y, Z. Okay? So, this, just don't know if that green marker is good enough. That's a vector equation of a plane. Now, a vector equation of a plane the X, Y, and Z are representing all the points on the line, or on the plane. Not line, plane. Okay. The A, the B, and the C, the coefficients, that is a perpendicular vector. So notice I'm changing the words. When we were talking about a line a minute ago, I kept talking about how you put a parallel vector in there. You put a parallel vector in there. Now, A, B, C is a perpendicular vector. You don't have to worry about finding a perpendicular vector. It will typically just be given. Okay, so they'll tell you, like an example, doesn't have a number to it. The last example on the page says, find a vector equation for plane M that being a keyword that we're doing something different than I was doing with that first example. That passes through the point 2, 3, 4 and is perpendicular to vector W, 1, -1, 4. Okay? So, I already have my equation of a plane there. The next thing I'm gonna do is put in this, just to show you this is really very similar to what our answer is gonna look like. The only difference is we need to have a number plugged in for D. Okay, so our answer is gonna look like this. It will just have a number there. How do I find the number there? I plug in the point. So once I plug in the point, I'll be able to find D. One, -1, 4 is my vector. 2, 3, 4 is my point on the plane. When I multiply, add that together, I get 15 for D. So my final answer for the vector equation of the plane is, going back to what I have written in blue here, final answer. Okay? That's the vector equation for the plane M. It is perpendicular to that vector, and it contains, sometimes they'll use the word contains, it contains that point. That point is on the plane. All right. You can, if you want, try that last page. Number 3 on the very last page is gonna be exactly like this, okay? 1 and 2 are gonna be what I did before this, the vector equation of the line. I will scan this answer key along with this video, and then maybe the next day or so I'll scan the answer key for homework 8, okay? And then I'll probably end up at some point doing like just a quick recap of stuff. We still haven't figured out if what we're gonna do for any sort of like assessment or anything like that. We're still working on figuring out how students turn things in, you know, on Google Classrooms. You know, we just don't do that very often for our class, well, ever for our classes, so this is all new to us. Big thing to keep in mind, the last thing we're gonna do for the year is gonna be the derivatives packet. The derivatives packet is the most important thing you need going into AP Calc next year, okay? It's also important if you're gonna go into a calculus class. If you're a senior and you're gonna go into a calculus class in college, it's gonna give you a leg up, okay? But it's definitely required for AP Calc next year. So, you know, we're gonna do our best here. All right, hope everybody's doing okay. All right, it's the end of the video. Do you wanna say hi now? Come here. You wanted to be in it. Oh, you could turn it off here. This is just Patrick saying hi. All right, here, I don't think they can see you. What do you wanna write? Show them what you can write. Can you write your name?
Yeah.
Okay, go ahead, write your name. Tell them how old you are.
4.
Okay. Oh. Thanks, dude. All right, go ahead, write your name. Did you drop your cup? Ooh, good job with the lowercase. Alright. Good. Can you write his name? What's his name? What's his name?
Charlie.
Charlie, go ahead, write it. Very good. Very good. Okay, do you want to read a word? Tell me what this word says.
Vector.
Very good. High five. Tell me what this word says.
Plane.
Very good. Okay, I'm gonna do a hard one. Ready?
Equation.
How'd you know that?
Plane.
There's no way you know that. No way. All right.
Let's erase all of it.
Okay. Let me do one more word and then we'll end it. Ready?
Driver.
Driver.
I don't know that word.
Derivative. It's okay. You're 4. You don't have to know that word. Okay. All right. Say bye, everybody.
Bye, everybody.